Okay, hello everybody. In this video, we are going to be going over some special cases. Okay, we've gone over lots of the different types of equations, linear equations that we are going to see, but there are times where the answer does not end up being nice and neat, like x equals 2 or x equals 5. It doesn't end up just being a single x solution, okay? So I'm going to go over a couple of these, and we're just going to see what happens, okay? So we're just going to try to solve these like normal, but you're going to see that with each of these problems, we're going to run into a little bit of an issue. Okay, they're not going to solve out nice and neat like the other ones that we've done. Okay, so if we look at number one here, 3x minus 7 equals 3x plus 4. Okay, and if we try to solve these for x, okay, right away you see that we're going to run into an issue, okay, for number one, because our first step, right, our first things to look for are, is there any distribution or is there anything to combine, like terms on either side, okay, and there's not, okay, which means we are ready to begin to cancel things out. And again, I recommend that we cancel out the variable term on the right side, okay, because that makes it look familiar, okay. But when we do that, right, 3x minus 3x is 0x, and that cancels, okay? But then when I go to do that on this side as well, I'm also doing 3x minus 3x, okay? And that canceled on the right side. That's also going to cancel on the left side too, because 3x minus 3x equals 0x, and that cancels that out as well, okay? So what happens here, right? Let's write just what's left. All I'm left with is negative 7 equals 4. And I'm no longer able to solve for x because there's no x's left. I canceled them all out, okay? So what's the deal here? What happens? And again, this is why it's called a special case, because it's not a normal type of problem. It's a special one, okay? Um, what happens here is that all the x's cancel, and I'm left with negative 7 equals 4. And you might be looking at that like, what? Negative 7 equals 4? That makes no sense, okay? And that's what I tell my students. When it makes no sense, right, that makes no sense. That does not comprehend. Negative 7 does not equal 4. So when it's no sense, we would say there's no solution, okay? There's no solution, right? A normal problem, a normal linear equation that we can solve has one solution, okay? Like I said, x equals 2, x equals 5, or whatever, right? That means that that one solution is the only one that can be true, okay? But for these special ones, one of the possibilities is that it has no solution. There are no numbers that we could substitute in for x to make this true, okay? So there's zero solutions or no solution, okay? And again, we know that it is no solution when our variables cancel, all of them, and there's no x's left, and we're left with this one number equals a different number. And that, again, that doesn't make any sense, so it's no solution. Okay, so that is one type of special case that we run into. Okay, another one that we run into is going to happen down here in number 2. Okay, so same thing. I would try to solve this. Okay, first I have to distribute here, right? And I have to do distribution on both sides. Okay, so I do that. I get negative 2 times 6x, negative 12x. Negative 2 times negative 2 is positive 4. And then on the right, 4 times negative 3x is negative 12x. 4 times 1 is positive 4. Okay, so at this point, if you're observant, you might notice that, hey, it's the exact same thing on both sides. Okay, and again, that's a little different. We don't usually see that, okay? But if I would still try to solve this, right, my next step would be to cancel one of my x terms. So I would try to plus this 12x to cancel out this negative 12x, and I would cancel that. And I'd plus 12x here on the right. And same thing, right? Negative 12 plus 12 is 0. Negative 12 plus 12 is 0 here as well, okay? And all my x's cancel, just like they did up here, okay? But what's important is I write what's left, okay? So here I have 4 equals 4. And you look at that, 4 equals 4. Well, that's technically true, right? 4 does equal 4. And okay, so that's true. 4 equals 4. And so when you're left with this, all the x's cancel and you are left with a true statement, 4 equals 4. And that might be like the simplest statement ever, but that is technically true. So in this case, our answer is not no solution, but we would say all real numbers. And I'll explain what that means. All real numbers. That means that, or sometimes you might see this fancy, like capital R with the extra little thing there. All real numbers means x could be anything. X could be any number. You could substitute any number in here for x, and it would be true. So another way to say this would be infinite number of solutions. Okay. So this one up top had no solution, 0. No number could work for x to put in here. But this is infinite solutions, or all real numbers. Any number you could put in for x, and that would be true. Okay. So those are some of the special ones we run into. And again, you know it's a special case when all of the x's cancel on both sides at the same time, and you're just left with numbers or constants on either side. And you have to look at, is it a number equal to a different number, or is it a number equal to itself? That'll tell you which type of special case solution that it is. Okay. Now, if you want, I have a third one up here. Okay, I'm telling you this is going to be one of your two situations, either no solution or all real numbers. And I want you guys to, you could pause the video and try and figure out which one this would be. Okay, and it's a proportion. So again, you start by cross multiplying. But take a minute or two if you want, pause the video and try to solve number 3 here yourself. Okay, I'm going to start it out here and figure this one out. Okay, number 3. So again, start out by cross multiplying, like I said. Okay, and again, these are groups up on the tops of these, which means I'm going to distribute. Okay, so if I do the top here times the bottom here, that is 4 times x plus 3. And then on the other side of the equal sign, I have the other bottom times the other top. So that's 2 times 2x plus 8. Okay, so there's my setup. Now I distribute. Okay, so I would get 4 times x is 4x. 4 times 3 is positive 12 equals 2 times 2x is 4x. 2 times 8 is 16. Okay. All right, and so if we continue to try and solve this, I would then try to cancel out one of my variable terms. So I would minus 4x from both sides. And what do you know? 4x minus 4x cancels. 4x minus 4x cancels. And what am I left with? I'm left with 12 equals 16. And again, that would be something that makes no sense. 12 does not equal 16. So if it makes no sense, it is no solution. There are 0 solutions, okay? No solution. All right. So there's just a little bit of some special cases that you might run into as you solve equations as well. And that's it. That's just about all the equations that we're going to try and solve, okay? So good job.